Hello everybody, I welcome all of you to this last lecture of this unit related to this unit, that is AC and DC bridge circuits. So probably in this lecture itself our last unit will be completed, and after that if we get lectures I will give some nice video related to our some important points in whole syllabus for your better understanding. Okay, so if we get time I will share that videos as well. Okay, so let's complete this unit in this lecture. Let's start with Wein bridge. Okay, so till now we have completed DC bridges, some AC bridges, and remaining AC bridges we have to complete in this lecture. Okay, now if you see this is schematic for Wein bridge. So it is an AC bridge used for measurement of a frequency. Okay, so in this lecture or in this type of this Wein bridge we will see how to calculate frequency with the help of these components. Okay, so for frequency measurement this schematic is used. Okay, now apart from this it is having some other applications, like it is used in harmonic distortion analyzer where it is used as a notch filter. Okay, so it is also used in some different types of audio and HF oscillators as a frequency determining element. Okay, you may have heard about the Wein bridge oscillator. Okay, so that is also dependent upon this Wein bridge. Okay, now if here if you carefully see this schematic, it consists of RC series circuit in one arm, that is R1C1, and there is another arm that is parallel combination of RC. Okay, so this is the series combination of RC, this is the parallel combination of RC. Okay, now again the bridge balance equation you know already, that is given by in terms of impedance, that is Z1 into Z4 is equal to Z2 into Z3, where Z1, if you see, this is your Z1 and that is nothing but your R1 minus J upon omega C1, because R1 and C1 are series. Okay, now like this suppose if you see Z2, so this Z2 is nothing but your R2. Similarly Z3, so Z3 is nothing but parallel combination of R3 and C3. Now here I think you have seen last lecture, and I think you remember that part. In one case we have replaced Z with admittance, that is 1 upon Z is equal to Y. So this 1 upon Z3 will be replaced, this Z3 will be replaced by we can say Y3, that is opposite term admittance. So here Y3 is written, that is opposite to this Z3. So Z3 is impedance and opposition of Z3 or opposite term of Z3 is admittance, which is written over here like this Y3. So is equal to 1 upon R3 plus J omega C3. So R3 is in denominator because this is exactly opposite to this one. Okay, so why this is done, you will get the idea about this in this slide only. Okay, so Z4 is equal to here R4. So like this, Z4 is equal to R4. Now see here what we have to do is that, suppose in here, suppose if I take this Z2 to this one side, and if you write this equation you will get Z1 Z4 divided by Z3. Again I am repeating, here we have to calculate in terms of Z2 suppose, then you will get term like this, Z1 into Z4 divided by Z3. So 1 upon Z3 should be replaced by this Y3. So this R2 is equal to this, R2 is equal to, so Z2 is replaced by R2. R2 is equal to, what is the Z1? Z1 is this one, that is R1 minus J upon omega C1. So R1 minus J upon omega C1. Then Z2 is equal to what? Z1 into Z4. So Z1 we have written, Z4 is nothing but your R4, that is written over here, and whatever the Z3 will be covered here, that is 1 upon Z3, that is written that is replaced by Y3 because it is exactly opposite to Z3. So Y3 is given here. So this equation is written in terms of Z2, that you have to keep in mind, that is Z3 into Z4 divided by Z3, or Z2 into Z3 into Z4 into Y3 we can say. So this is written over here. Now if you again solve this, if you multiply this, you will get an equation like this, that is R2 is equal to R1 into R4 divided by R3 minus J R4 divided by omega R3 C1 plus J omega R1 R4 C3 plus C3 into R4 divided by C1. Okay, now the same procedure that we have to apply here also, that is we can equal or equate real terms, or we can separate real terms and imaginary terms. If you separate real terms and if you equate real terms, you will get R2 is equal to what? This R1 into R4 divided by R3 plus C3 into R4 divided by C1. Okay, so here if you calculate this in terms of R2 divided by R4, which can be given like this, R1 divided by R3 plus C3 divided by C1. Okay, so keep this formula in your mind, this is very important. Okay, so now if you equate the imaginary terms, you will get the equation like this. So again if you take this to this side, right side, and remove some terms, then you will get the equation like this, and finally you will get something like this, that is omega square is omega square into R1 into C3 into C1 into C3 is equal to 1. Okay, so see carefully which terms are cancelled and which terms are written over here. Okay, now here omega square is equal to 1 upon R1 R3 C1 C3. Okay, and omega is equal to 2 pi f, you know, I think omega is equal to 2 pi f, and here if you see, that is 1 upon, if you take square root of this, you will get 1 upon under root R1 into R3 into C1 into C3. So omega is equal to 2 pi f, we have equated this with this one, and if you find the frequency over here, you will get f is equal to 1 upon 2 pi under root C1 C3 into R1 C3. Okay, now here we have to choose the value in such a way that we will get some simplified equation. So here we can consider the value of R1 and R3 is equal and can be denoted by R. Similarly, suppose the value of C1 and C3 are similar, so we are talking about these values. Okay, so C1 and C3 are equal, and suppose they are denoted by C, then if you put these values to this equation, whatever we have calculated earlier, that is R2 divided by R4 is equal to 2. So this ratio we are getting, that you have to keep in mind. So in terms of other we can say scenario, I can say that R2 is equal to 2R4. Okay, so that also you can take. Okay, such a value you have to select, and the most important thing that we are interested, that is f is equal to 1 upon 2 pi RC, because if you replace this these values here, okay, so you will get the equation like this. So here this is very simple, that in a simplified way you can calculate the frequency, that is f is equal to 1 upon 2 pi RC. Okay, so I think you got the idea behind this. Okay, so this is the equation which gives the frequency determination of a Wein bridge. Okay, practically C1 and C3 are fixed capacitors and R1 and R3 are variable resistors, we can say. So here C1 and C3 are kept as a constant and R1 and R3 are variable. Okay, that you can observe from this circuit. Okay, so here if you talk about the frequency measurement range, it can vary from 100 Hz to 100 kilohertz, and you can get the accuracy about 0.1 to 0.5%. Okay, and it is also used for measurement of a capacitor as well. Okay, so here if you see this equation, this can be written in terms of capacitance also, so that's why you can use this for measurement of a capacitor. So this was all about the Wein bridge, and we have seen how to calculate the frequency with the help of these different equations. Okay, so now let's move towards the next type of a bridge, that is de Sauty's bridge. Okay, so this is very simple bridge. Till now we have discussed so many bridge circuits, AC bridge circuits. Out of that I can say that this is the simplest type of a bridge. Okay, so it is simplest method for measurement of a capacitance, that you have to keep in mind, because here if you see, this is R1, this is R2, this is Cx and this is a C3. So Cx is unknown capacitor or capacitance. So this is your E1, so you can calculate the drop across this one. This similarly, this is E2, this is E4, and this is a E3. Okay, so this is a very simple bridge. Okay, so we know that the equation of balanced bridge is Z1 into Zx is equal to Z2 into Z3. Okay, so here you will get the equation like this: Z1 is equal to R1. Okay, because there is no any, we can say, capacity on inductive terms, so Z1 is directly equal to R1. Then similarly Z2 is R2, Z3 is 1 upon j omega C3, because here no resistive part is there, so directly Z3 is 1 upon j omega C3, and Zx is 1 upon j omega Cx. Okay, now if you put all this value into this equation, this balanced bridge equation, we can say, you will get the values like this, that is R1 into 1 upon j omega Cx is equal to R2 into 1 upon j omega C3. Okay, so now if you remove this part, the common part from this, and if you equate this equation, you will get the equation like this, that is R1 upon R3 into C3 is equal to Cx. Okay, so here there is one modification that you have to do, that is, it is not R3, this is R2, because if you see this R2 will come here, over here, so there is printing mistake that you have to denote. So C3 will go over here, and we can say here you will get R1 divided by R2 into C3 is equal to Cx. So one modification that you have to do is replace this R3 with R2. Okay, so that is only modification, there is printing mistake. Again I am explaining this. If you take this Cx to this side and C3 and R2 to this side, so C3 will become numerator and R2 will become denominator, and this, there is printing mistake, replace this R3 with R2. Okay, so this is all about the de Sauty's bridge. Okay, so let us move towards the last bridge. Here I have not covered that phasor diagram, that is very simple, you can refer in book or you can draw by yourself. Okay, now here the last type of a bridge that we have to study, that is Schering bridge, we can say. Okay, so we have to move towards the Schering bridge, but before that, if you see this de Sauty bridge, again if you see the advantages, it is very simple and the simple diagram is there, number of components are less, so that's why it is more economical bridge. But there is one disadvantage, that this capacitor should be accurate and must not be having any dielectric losses. So if they face any dielectric loss, then it is not possible to achieve the balance of this bridge. So balance of this bridge mainly depends upon the dielectric loss. Okay, so for that there is one remedy, we can say, that is, you can replace this capacitance with some lossless capacitors. And if you talk about the lossless capacitor, you can choose air capacitors for that. So there is only one need, that is, if you want accuracy, then you have to replace these capacitors with air capacitors. Okay, so this is one modification in this. So last type of a bridge, that is a Schering bridge, that we have to see now. The circuit arrangement is shown over here. Okay, and right side shows you the phasor diagram for that. So again, if you see, it is used extensively for the measurement of capacitors, because here you can see the unknown capacitance value is there. So by observing the circuit diagram of bridge only, you can tell what is the use of this bridge. Means where there is x quantity, that is unknown quantity, and that bridge is used for measurement of that quantity. So here you are getting Cx over here, means what, this bridge is used for measurement of unknown capacitance. Okay, so it is also useful for measuring insulating properties, that is phase angles, where that is very nearly to 90 degrees. Okay, so if you see, this is the basic diagram of Schering bridge, and here one of the ratio arm consists of resistance in parallel with capacitor. So here this is arm which will give you the diagram like this, R1 and C1 are parallel, and with a capacitor, and standard arm consisting of capacitor only. So this is the standard arm having the known value of capacitance, and that is a C3. There is no any resistor in this. Okay, so if you compare all other bridges with each other, there is only slight difference. Okay, so again the equation, way of equation, and the method that you have to use for calculating the equations is same. Just there is some interchange places of the components are there, like inductor, capacitors, resistors, and based upon that only you will get the values. Okay, so if you talk about the standard capacitor, that is here, that capacitor is high quality mica capacitor, or you can use air capacitor also. Okay, so let us talk about the equation. So general bridge balance equation, you know, that is Z1 Zx is equal to Z2 Z3. Okay, so here we can write Zx is equal to Z2 Z3 divided by Z1. So Z1 is replaced by Y1. So here again printing mistake is there, you have to replace with this Z2. Okay, so here this equation is Z2 Z3 divided by Z1, and 1 upon Z1 is replaced by Y1. So that's why you will get the equation like this, that is Zx is equal to Z2 Z3 into Y1. Okay, so here again if you talk about the Y1, that is admittance opposite to Z1, so it can be related to this arm. So you will get like this, 1 upon R1 plus J omega C1. Then Z2 is equal to R2, and Z3 is having only capacitance, so that's why you will get like minus J divided by omega C3. And similarly, if you take Zx, that is R plus 1 upon J omega Cx. Okay, so this is all about the values that you get here over here. Okay, now if you substitute these values in this equation, you will get Rx minus J Rx minus J divided by omega Cx is equal to R2 into minus J divided by omega C3 into bracket 1 upon R1 plus J omega C1. And again if you multiply this inside, you will get the equation like this. Okay, and if you see this equation, and if you separate the real and imaginary terms over here, you will get the real terms like this: Rx is equal to R2 C1 divided by C3. Okay, and here we can say that Cx is equal to R1 C3 divided by R2. Okay, and 1 upon omega Cx is equal to R2 divided by omega R1 C1. Okay, if you replace we can say that imaginary parts, or equate the imaginary parts. Okay, so here from real terms Rx is written over here, and from imaginary terms you are getting the value of Cx. Okay, and the Cx is R1 into C3 divided by R2. So in this way the Rx is also we can get here, but we are interested in Cx because it is extensively used for measurement of capacitors, this bridge, Schering bridge. Okay, so Cx is equal to R1 into C3 divided by R2. Okay, so this was all about the this unit that we have seen, that is AC and DC bridges. Okay, so if you see your syllabus, almost each and every point of this unit we have completed. Okay, and this is very simple, that's why we required very less time to complete this unit. So you just carefully keep the circuit diagrams in your mind. There is slight difference in between each and every bridge. See different types of the bridge like DC bridge, AC bridge, and just draw the diagram by watching my videos, and try to write the equation by your own. Once you write the equation, then for another time you will not require to revise that point, because once you write that equation by your own, that will be fitted in your mind. Okay, or memory. So this was all about this unit that we have completed. Okay, so this was the unit number 6, AC and DC bridges. So with this we have completed our syllabus as well. Okay, so I will try to give you some nice videos to some important points in this syllabus, not this related to unit only, this unit only. So I will share this video directly with you, and you can watch that video, because if you see this second section, that is oscilloscope, function generators. So all these are we can say practical equipments, and we don't have any practical to this subject. So that's why I will try to share some nice videos which are available on YouTube with you. You just go through that videos and try to make your own notes and see which types of new addition is there, new type of equipments are available over here, because whatever you are using in lab, that is traditional, but nowadays in market there are different types of additional equipments with some additional and nice facility they are available. For example, if you see CRO nowadays CRO comes with function generators, signal analyzers, spectrum analyzers, so all in one, we can say. So that's why I am telling you that see whatever is going in this instrument industry, and which are the new instruments are available and mostly used in industry. So I will share that videos with you, don't worry about that. And up to this is your last lecture that I have recorded for you, and I wish you best of luck for this subject. If you feel any query about any point, then you can contact to me. Okay, so best of luck for your examination. Okay, so just see my each and every lecture that I have made one playlist named as instrumentation and measurement, and share with your friends who require that. Okay, so that will be lifetime on YouTube. You can refer that in future as well. Okay, so thank you very much. So it was very nice interaction with you, and wish you best of luck for your future. Thank you. So with this, we have completed this playlist, that is measurement and instrumentation. Thank you.